This is a video to serve as a brief introduction into electrical protection schemes and it is to form part of a small series. So, to begin with, electrical protection is a necessity in all electrical systems around the world, and as such, it is important to at least have a very basic understanding of what they are. So, to begin with, we have electrical protection schemes. An electrical protection scheme consists of protective devices, circuit breakers, relays to activate those circuit breakers, fuses to detect overcurrents and short circuits and break them in a fast period of time. And each of those has different complications on your design. So there's not always one easy cut answer, which many people will have their preferences towards circuit breakers or fuses, particular usage of different combinations of relays and protection schemes in their systems. However, this is part of the beauty of electrical design. So, as stated, this is a basic introduction. And as such, the importance of the electrical protection scheme must be described. So, as it states on the screen, a correctly designed scheme will protect people. So, anyone near the equipment, whether it's personnel inside the substation, people working around the substation, if it's an integral substation to a factory, let's say, no one outside will be hurt. The equipment itself will be safeguarded from having a major catastrophe, such as a major arcing incident, which can result in this specific case, we're focusing on equipment, so the equipment being catastrophically destroyed, and therefore you have downtime in the form of perhaps a key building has been cut off electrically. This could be either an industrial application, such as a factory producing a company's key components for their sales, a medical hospital environment could have their entire supply cut off. Now, obviously, this is a bit different because they do have some resilience built in. However, there will be a major downtime, which is the key important thing here. Besides the fact that there is also a massive cost of replacing such equipment, and before that, there also has to be investigative um, studies on why the incident occurred in the first place. The next bit, which kind of touched on already, was ensure supply continuity. You would basically want to make sure that the supply to the building and area isn't lost. So we do this by ensuring that the electrical fault is quickly broken, the abnormal electrical condition detected, and the fault removed from the network so as to not cause further disruption to any parallel parts of the network. This is known as selectivity and coordination, and there's many different parts that can play into it, such as the components about to be mentioned. So, mentioned earlier was fuses. There's different types of electrical fault. Two key ones to focus on: overcurrent, short circuit. Overcurrent can not necessarily be an issue, but it's just when the load begins to take an excessive amount of current. This could be either due to, like I just said there's no issue with the load, but it could be to do with an issue with the load. Maybe a motor's failing, or it could simply be that the circuit's not designed correctly, or something was plugged in on a circuit which shouldn't have been plugged in, and it started to draw excessive current. Either way, this fuse can detect this current and trip it in a slower time than the next type of fault called a short circuit, where, for example, there has been a cable cut by a contractor, and now there's electricity flowing to the ground, trying to get back to its source. Another fault occurred, and with that, an extremely high current is flowing. The fuse will almost instantly disconnect it. This electrical circuit, protecting both the upstream protection and circuits, including transformers, whilst also ensuring that it activates and breaks the circuit faster than the upstream protection in order to ensure that parallel systems of protection aren't activated, ensuring continuity of supply. So, very good, very quick, very predictable. Quickly going through the list. Instantaneous protection, as just mentioned, can be as low as 0.02 seconds. The predictable, you get a manufacturer's data sheet, tells you exactly its operating ranges. Brilliant. You can coordinate it against further downstream. There's a pre-arcing and arcing stage. Again, these can be used to look at the downstream protection and ensure it doesn't trip. The fuse element will melt to disconnect the circuit. It can't be reused. In the event, a little bit of information. Say if you have 3 fuses for a 3-phase system, one of them trips, you replace all of them because you don't know the actual condition of the fuse. It might look okay, but you can't take that risk of next time it not activating. So, let's replace all 3. Great thing about this, your fuse is blown. Flick it back on. You can't do that. Not like a circuit breaker. That means that in the event you get somebody trying to just turn the circuit back on, like your light switch is turned off, just put it back on. Can't do that. It ensures that the actual issue is going to be remedied without possibly causing further issue by introducing the fault back onto the network, even if it is momentarily. And as mentioned, it's easy to coordinate with downstream fuses. Yeah, brilliant. Fuses. Next thing, circuit breakers. Circuit breakers, I'll try and keep this one a bit faster. Circuit breakers offer overcurrent protection. They have different means for this. Could be thermal, magnetic, electromagnetic. Either way, they have an adjustable trip setting for both overload, short circuit, and also the time delay. They have different dials that you can set. Some of them even have an ability to change the software. Brilliant. Electromagnetic strip mechanisms can be used, like I said. They're more flexible. You can take a protection curve and you can line it up against the next downstream or upstream. You can ensure that there's no overlaps and you can put them down to more precise values to ensure discrimination or what is now known as selectivity. Brilliant. The only downside is a circuit breaker will not trip as fast as a fuse. We mentioned earlier 0.02 seconds for a fuse to trip in the best case scenario, depending on the type. And the type of fuse and the type of fault. A circuit breaker, depending again on the type and the protection settings, it could take up to a second to trip. The calculations for this I'm not showing here, however, it is something to be very mindful of. However, the circuit breaker can be more fine-tuned, which is fantastic about it. And it does lead to it being used more often for discrimination purposes and selectivity. Um, Again, data sheets are available. You can come with different settings already pre-programmed. They're quite easy to set up as well. Some of them, literally, you go to the front of the circuit breaker, you use the trip unit, and you just set whatever you want your trip, um, what I like to call plug setting as, and that's in relation to your CTs. They are reusable after a trip. providing that it's not catastrophic. Again, that is up to the intelligent operator to look at. Um, However, they aren't one-time uses, especially with such expensive equipment, which can cost maybe £30,000, for example. One great thing, you can remove the fault and you can put it back on. That's, for example, if it did nuisance trip, the fuse wouldn't be able to. You can't reclose the fuse. It's popped, so to say. But the circuit breaker, the connections can be reclosed, providing it's safe to do so. Finally, they can be more complicated to coordinate, especially as you get to the point from which there may be milliseconds between the upstream and downstream protection, in which case there may be something else that needs to be done. But yeah, overall, those are two main devices used in protection schemes which play a fundamental role. Everything else revolves around these. So yeah, please watch the next video to find out a bit more about relays, current transformers, voltage transformers, and how they're used, what systems they're used in. Thank you for your time. Goodbye.